Protostar. Protostars represent the earliest stage in a star's life. They form inside cold clouds of gas and dust where gravity slowly pulls material together into a growing object. At this point, nuclear fusion has not fully begun, so the young star is still gathering mass and heating up. Over time, as the core becomes hotter and denser, the protostar finally ignites and begins its long journey as a true star. Brown dwarf. Brown dwarfs are often called failed stars because they never become massive enough to sustain normal hydrogen fusion. They form in much the same way as stars, but their limited mass keeps them somewhere between the largest planets and the smallest stars. They emit only faint light, mostly in infrared wavelengths, making them difficult to detect. Brown dwarfs help scientists understand the boundary between planets and true stars. The Dwarf Family. Red dwarf. Red dwarfs are the smallest and coolest true stars in the universe. They form the same way as larger stars, from clouds of gas and dust, but they never gather enough mass to burn their fuel quickly. Because they use hydrogen at a very slow rate, they can shine for trillions of years, making them the longest-lived stars known. Most stars in the Milky Way are red dwarfs, and many planets have been found orbiting them, making these quiet stars important in the search for life beyond Earth. Orange dwarf. Orange dwarfs sit between red and yellow dwarfs in both size and temperature. They are slightly cooler than the Sun but warmer than red dwarfs, giving them a soft orange color. These stars burn their fuel slowly and remain stable for tens of billions of years. Many astronomers consider them excellent candidates for hosting habitable planets because they combine long lifetimes with relatively calm behavior. Yellow dwarf. Yellow dwarfs are medium-sized stars that produce a steady amount of light and heat for billions of years. Our own Sun belongs to this group, even though it actually appears white when seen from space. A yellow dwarf spends most of its life turning hydrogen into helium in its core, creating the energy that supports planets and their climates. Their long, stable lifetime gives life enough time to develop, which is one reason they are studied so closely. Red giant. Red giants appear when stars similar to the Sun begin reaching the end of their main life stage. As hydrogen in the core runs low, the outer layers expand dramatically while the surface cools, giving the star its deep red appearance. A red giant can grow hundreds of times larger than it once was, sometimes large enough to swallow nearby planets. This stage marks an important transition before the star eventually sheds its outer layers. The giants. Blue giant. Blue giants are massive, extremely hot stars that shine with a bright blue-white color. Their enormous mass allows them to produce huge amounts of energy, but it also causes them to burn through their fuel very quickly. Instead of lasting billions of years like the Sun, they often survive for only a few million years. Even though their lives are short, they play a major role in creating heavy elements that later become part of new stars, planets, and even living things. Blue supergiant. Blue supergiants are some of the brightest stars in the universe. They are much larger and more massive than the Sun, with extremely hot surfaces that give off intense blue light. Their strong radiation and powerful stellar winds shape the regions around them, influencing the birth of future stars. Because they burn fuel at such a rapid pace, they have very short lifetimes before ending in dramatic explosions. Red supergiant. Red supergiants are among the largest stars ever discovered by size. They begin as very massive stars and expand into enormous objects near the end of their lives. Although their surfaces are relatively cool, their immense size makes them incredibly bright. Famous stars like Betelgeuse belong to this group. These giants eventually explode as powerful supernovae, spreading newly formed elements across space. Wolf-Rayet Star. Wolf-Rayet stars are extremely hot, massive stars nearing the end of their lives. They have shed much of their outer hydrogen layers through powerful stellar winds, exposing the hotter material underneath. These stars lose mass at an extraordinary rate and shine with incredible intensity. Their final explosions enrich space with heavy elements that later become part of new generations of stars and planets. White dwarf. White dwarfs are the small, dense remains left behind after stars like the Sun finish their lives. Once the outer layers drift away into space, only the hot core remains. A white dwarf is about the size of Earth, but can contain roughly the same mass as the Sun, making it incredibly dense. It no longer creates energy through nuclear fusion and slowly cools over billions of years while continuing to glow from its leftover heat. The violent deaths. Neutron star. Neutron stars are created when massive stars explode as supernovae and their cores collapse under tremendous gravity. Almost all of the matter inside becomes tightly packed neutrons, producing an object only about 20 kilometers across, but heavier than the Sun. Their gravity is so strong that a teaspoon of neutron star material would weigh billions of tons on Earth. Some spin hundreds of times every second and send out beams of radiation, appearing as pulsars when those beams sweep across our view. Pulsar. Pulsars are rapidly rotating neutron stars that emit narrow beams of radio waves, X-rays, or other forms of radiation from their magnetic poles. As the star spins, these beams flash across space like the beam from a lighthouse. If Earth happens to lie in the beam's path, astronomers detect regular pulses with astonishing precision. These steady signals have helped scientists test theories of gravity and study the extreme conditions found in collapsed stars. Magnetar. Magnetars are a rare type of neutron star with the strongest magnetic fields ever observed. Their magnetic force is so intense that it can affect atoms from enormous distances. From time to time, magnetars release bursts of high-energy radiation that can briefly outshine many other objects in the galaxy. Although they are uncommon, they provide valuable clues about how matter behaves under the most extreme physical conditions. Variable stars. Binary stars. Variable stars are stars whose brightness changes over time. In some cases, the star naturally expands and contracts, while in others, another object passes in front of it or pulls material away. These changing patterns are more than simple curiosities. Certain variable stars act as reliable distance markers, allowing astronomers to measure the scale of our galaxy and the wider universe with remarkable accuracy. Binary stars are systems where two stars orbit a common center of gravity. They form together from the same cloud of gas or become linked through gravitational interactions. Their movement reveals valuable information about stellar mass, which is one of the most important properties of any star. Many stars in the night sky are actually part of binary systems rather than living alone.